Each orbital can hold at most 2 electrons, and those two must have opposite spins, so no 2 electrons in the same atom have identical sets of quantum numbers. Think of an orbital as a tiny room that can fit 2 kids, but they must sit facing opposite directions, so they are not doing exactly the same thing. That opposite facing is the electron spin being opposite. When you add 1 electron to an empty orbital, it can have either spin up or spin down. But if you add a second, it must be the opposite spin, and you cannot add a third because the room is full. This rule comes from the Pauli exclusion principle, which says no 2 electrons in an atom can share the same 4 quantum numbers, so the orbital limit and opposite spins keep each electron unique. When filling many orbitals in an atom, you follow this rule together, with Hund's rule and the energy order, to determine where electrons go. A common mistake is thinking spins are physical directions like up and down in space rather than quantum properties. Remember, spin is a quantum label, not literal orientation, and it simply must differ for 2 electrons in 1 orbital. Another error is trying to put 3 electrons into 1 orbital because people imagine more can squeeze in. The rule forbids a 3rd electron in the same orbital, so you must occupy other orbitals. A third misconception is ignoring the role of quantum numbers, so students sometimes think identical electrons are allowed. Always check that at least 1 quantum number differs. Check www.gumballdegree.com for more videos and resources on how electrons fill orbitals and follow the Pauli exclusion principle.